Good day, everyone. We're going to be doing the Unit 3 study guide, which is on parallel and transversals, and also on logic. All right, so for number one, the first thing we're going to do is we're going to do a little recap. So I already wrote a little bit of notes here just as a reminder. So corresponding angles are on the same position. It's like a copy paste. So if you look at this train station to this train station, see how that's in the top left corner? That's also in the top left corner. So it feels like a copy paste job. Alternate interior, they're on alternate sides of the train tracks. So on the one's on the left side of the transversal, the other one's on the right side of the transversal, and they're both inside of the possible parallel lines. And these lines could be parallel or not. The relationship will always be true. But the equation, whether it be equal or add up to 180, depends if these lines are parallel. All right, so alternate exterior, they're on alternate sides of the transversal, and they are outside the parallel lines. And this one, they're on the same side, but they're all interior angles. So this is interior, that's interior. They're on the same side of the train track, so that's same side interior, or a better name for that is consecutive interior. All right, so now that we have a little refresher of that, let's go ahead and do these problems. Okay, so first of all, 1 and 2. So see this right here? That does not, it kind of looks like we're going along the N line, but what we really want to do is if we draw lines instead of these pieces of wood, you might be able to tell just a little better as to if you're moving or not. So I'm just going to draw these little lines, and hopefully that makes a little more sense to you. And you should do the same thing. All right, so here we go. So 2 and 8. So here's 2, here's 8. So 2 and 8. What train? So 2 is at this train station, that's the vertex, and 8 is at this train station. What train did you take? And that will be the L train. Okay, now what is a relationship? If I redrew this a little bit, you might be able to see it better. So here is 2 is right here, and 8 is right here. Are they on the same side or alternate sides? They're on alternate sides, and they're both inside of the parallel lines. So that is alternate interior. All right, let's go to the next one. 7 and 3. So here is 7, and here's 3. Is there a train that took you straight from 7 to 3? No, there's not. So there's not a straight train from 7 to 3, so there is no transversal. And if there's no transversal and you're not at the same train station, you're not going to have a relationship. I would have to take 2 trains to get there, so there's not going to be a relationship between 7 and 3. So there is none for the relationship. All right, how about 1 and 2? Now 1 is here and 2 is also at this train station. So we didn't actually take a train. We didn't even leave the station. So there is no transversal. However, there is still a relationship between this. Now, let me give you a little bit more notes here. So if we're at the same train station, there are a couple different ones that can be. It could be vertical, which could be here or here, or here or here, right? So those are vertical angles. And then there's also, same lines here. It could be this one and this one, or this one and this one. Now, if I do this, we have this angle and this angle, right? So these angles right here, together they make a rainbow of a straight line. And that would be a linear pair. So this, a lot of people get these two backwards, but this and this, together they don't make a rainbow of a straight line. These do. So this and this, together they make a rainbow of a straight line. So that is a linear pair, a pair of angles that create that make a line. So on this one, we have 1 and 2. They're at the same train station, but on this, is it vertical or a linear pair? Those two are a linear pair. So linear pair. So those are, but there's not a transversal. All right, number 4. We have 6, which is right here, and 7, which is right here. What train took you from 6 to 7? So here's the train right here, and that is the Q train. And we always want our train to be vertical to us. That one simple action makes things a lot more clear. All right, so 6 and 7. So here's 6, here's 7. So if I redrew this a little bit, the picture would have looked like this, where this is 7 right there, and here's 6 here. Okay, so are they on the same side or alternate sides? They're on the same side, but only 6 is on the inside. So, so if it's not same side interior, then maybe consecutive, maybe it is corresponding, which they are. This is the top right corner, that's the top right corner. So those are corresponding, and I just write CORR. And number 5, we have 3 and 4. Here's 3, here's 4. So if I just cover this up, 3 and 4, what train did you take to get from 3 to 4? That would be the M train. And those right there, if I just focus just on that, nothing else, they're on the same side, and they're both inside of these lines right here. So if I redrew this, you might be able to see a little better. So here's 3, here's 4. So I'm just focused on those. They're on the same side, and they're both inside those two lines, those two possible parallel lines. So that so we took the M train, which we rewrote, and then on top of that, that is same side interior or consecutive interior. Both mean the same thing, but consecutive interior is the better vocabulary word. And finally, 8 to 7. So here's 8, here's 7. Is there a train that went straight from 8 to 7? No, there's not. There's not a straight train, and they're not at the same station either. So it's not vertical or linear pair. So there is none for the relationship. All right, so that was number 1. Let's keep going. Number 2. All right, so for number 2, they actually told us, they were really nice enough to actually say that what x is. So x is 9. All right, so x is 9, and they said angle 3 is 5x plus 18. So all we have to do is plug that in. So in my calculator, and I'll show my calculator as I type this in. All right, we have 5 times 9 plus 18. So that is 63. And then we have 17 times 9 minus 36. And also we have 9 times 9 plus 36. Cool. All right, so we have these numbers right here. So this was 63, this is 117, and this is also 117. Okay, as soon as we get that, we want to put that in this picture. Now, when I put this in the picture, there's not a lot of room here. This is really a small picture. So if I put this in the picture, you're not going to be able to see things very clearly. If I write it right in here, 63, this is going to be really bad. 117 and 117. See, I can barely read those numbers. So the better thing you can do is actually redraw this. So I'm going to draw this over here on the right side, nice and large, so I can actually read what I'm doing. So I'm making it big enough so that I can actually put numbers and they're not going to be right on top of each other. So this is L, M, and N. Over here we have J and we have K. And we just found out that this angle right here was 63. We found this angle right here was 117. And this angle over here was 117. And I put that in dark or pen or blue. And now I'm going to change my colors, or I'm going to change over the pencil. And now I can find all these other angles. Now this angle has nothing to do with these over here. I cannot jump from this line to this line because I don't know if they're parallel. But I can find all 4 corners. I know that these are vertical, so this is 63 as well. I'm going to zoom in a little more. And then on top of that, I know that this and this add up to 180. So if I take 180, show my calculator so you can see what I'm typing and what's going on in my head. 180, subtract that 63. So this angle right here would be 117, which just happens to be the same numbers as these. It doesn't have to be. And this would be 117. So all of that, we have all 4 corners. Now, completely separate from that, let's find this. This is 117, this is 117, and 180, subtract 117, and this would be 63, and this would be 63. Over here, this is 117, 117, And I already did this one earlier, so that would end up being 63. And this is 63. Excellent. All right, so we have all four corners here, all four corners here, all four corners here. Now the question is, are any of those exactly the same? So is anything a copy-paste job of this? Well, that's in the top left corner, this is 63. Top left corner, this is 117, so that's not working. And this right here is 63. So this and this are exactly the same. So these are the two parallel lines. So L is parallel to N. And that's what they were trying to figure out. So the answer, so what they were asking for was what was parallel, and that was L is parallel to N. Fabulous. Let's keep going. All right, number 3 is exactly the same. So we have, they were nice enough to actually tell us that x was equal to 9, or sorry, x is equal to 6, because I know my numbers. And we can actually find these. What was angle 1, angle 3, angle 4, and angle 11. And what we're going to do is we're going to just plug 6 into here. So plug 6 into here and see what you get. So 15 times 6 plus 7, and what numbers do you pop out with? So I get, when I plug this into here, when I plug this into here, when I plug 6 into these x's, I pop out with 97, 89, 83, and 97. So when I plug those in. So when we're going to put that into the picture and see which ones are parallel. So the same thing as what you did a minute ago, and we're going to see what's parallel. All right, so angle 1 was 97. Angle 3 was 89. Angle 4 was 83. And angle 11 was 97. So we found those numbers right there. Okay, so what I can do is I can find these four corners. I can find these four corners. I can find those four corners. So if I put that in there, 97, 83, that makes 180. That's perfect. This would be 83, and this would be 97. Over here, 97, 97. This be 83, that'd be 83. Oh, and this is 89. So this, to complete 180 degrees, would have to be 91 to complete 180. Over here would be 89, and over here would be 83. All right, do any of these look like a copy-paste job? Let's see. In the top left corner, there's 97, there's 97, there's 89. So it's these two right here, which are parallel. So let's see. Is M parallel to N? Yes. Is N and O parallel? No, because those did not match. So that's a no. And is M parallel to O? No, because those... oh, that was supposed to be 91. 91 right there. Sorry for that typo. Okay, and that would be no, because those do not match. Okay, excellent. So you have 1, 2, and 3 done so far. Let's keep going. All right, number 4. So on this, we want to see which things are equal, which things add up to 180. All right, so we have more x's. So we have this x and this x right here. Now, these two, what do you think they do? Do you think they equal each other, meaning that they're the exact same thing, or do you think they add up to 180 to complete a straight line? Well, these together complete a straight line, so they complete 180 degrees. So we know, I'm going to move this over here, we know that these two, the first one plus the second one equals 180. And it's really smart to actually just put parentheses first, equals 180. That way, when you plug it in, you don't accidentally set them equal to each other, which is a very common mistake. All right, so we know that 29x minus 3 plus the 15x plus 7 is equal to 180. All right, so we're going to combine like terms. So 29 and 15, that makes 44x. Negative 3 plus a 7 makes a positive 4. Okay, and now we're going to solve. We're going to subtract 4 from both sides. So 180 minus 4, we get 44x equals 176. Divide by 44, and I got x equals 4. And what are you supposed to do as soon as you get x? you always want to plug it back into the picture for two reasons. One, to check yourself. Does that make logical sense? Does this plus this equal 180? Does it look correct? So that's the first reason. And the second reason is to help you find everything else. So when I put this in the calculator, so I'm going to show my calculator so you can see what I'm doing. I'm plugging that back into the very, very original. And I mean the original, because if you plug it into here and you made a typo, you're just building off of your mistake. So I don't want to plug it into here. I want to plug it back into the thing that they actually wrote themselves. So 29 times 4 minus 3. This right here is 113. Right here, 15 times 4 plus 7, and I pop out with 67. Once you have that, you should be able to find all the corners. Right here would be 113, and notice that I'm putting it as far into the corner as I can, and this right here would be 67. Now that I've found all four corners here, I can copy paste it over here. This would be 113, this would be 67, this would be 113, and this would also be 67. Excellent. Now I feel really good about this, and I can now solve for y. I know that this and this are the same angle. If they're the same angle, that means that they are equal to each other. So I know that 13y minus 17 is equal to 113, and now I can solve. So I can add 17 to both sides. 113 plus 17, I get 13y is equal to 130. Divide by that 13, and I pop out with y equals 10. And as soon as I find y, I want to plug it back into here just to double check that it works. Because I want to make sure that I'm not building off of mistakes. I'm checking myself. So let's plug it back into here. It's 13 times 10 minus 17. Does it pop out with 113? Yes, it does. I feel really good about both of those. And that's the answer for 4. All right, let's keep moving on. Number 5. Number 5 is a really good one. So number 5, here's the catch. So parallel lines, I'm making them the same color, right? But this is a line all by itself, so that's yellow. And this is a completely different line, so I'm going to make that orange. Now here's the thing. The obtuse of the green to the yellow, the big angle is not going to be the same thing as the big angle from green to orange. These are different colors, so they don't match. Whereas over here, from earlier, if I had this and this, notice that the obtuse of green to orange was the same thing as the obtuse from green to orange. The acute from green to orange was the same thing as the acute from green to orange, as long as they were the same colors. And why did we make both of these green? It's because they're parallel. So if they're parallel lines, you can make them the same color. So all three of these were parallel, so I made them all the same color. This is its own line. There's nothing parallel to it, so I gave it its own color. And this is a third line that has its own color because it's not parallel to anything else. All right, so basically, yellow and green is its own problem, and then orange to green is a totally different problem. All right, let's solve these. All right, so this right here, we have, do you think that these two angles equal or add up to 180? Well, this one is obtuse, this one's acute. They are different, so they're going to add up to 180. So we have 8x minus 7 plus that 3x minus 11 is equal to 180. So that plus that equals 180. Perfect. And you're going to solve. All right. So I'll leave that up to you guys. You guys should be able to solve because we did an example of that earlier. All right. Over here, brand new problem. And when you're done, you always plug it back in, right? Over here, we're going to do this one as well. We have, now, do you think that this and this are equal, or do you think they add up to 180? They are going to be equal to each other because they are both acute. So 2y plus 23 is equal to 4y plus 8. So you're going to solve. So let's go ahead and solve that. We're going to subtract 4y from both sides. I get negative 2y plus 23 is equal to a positive 8. I'm going to subtract 23 from both sides of the equal sign. I get negative 2y is equal to negative 15. And I'm going to divide both sides by negative 2. And I pop out with y equals a positive 7.5. And they didn't say anything about rounding, so and that's beautiful, so I'm going to leave it at 7.5. Now, as soon as I get y, I need to plug it back into the picture. That will help me find z. 2 times 7.5 plus 23, I get that this is 38. And over here, 4 times 7.5 plus 8, I get 38. And now that I have that both of these, and they're supposed to be equal, so that works. This is 38 and that's 38. How would I find over here? I know 180 subtract 38 would have to be 142. So what I did was I took 180, I subtracted 38 to get the leftover, so that's 142. And over here, it'd also be 142. So this is 38, this is 142, that's 38, that's 142. How do I find z? So to find z, I know that this angle is 3z minus 5. It is also 142. If they are the same angle, they are equal to each other. So I set them equal, and it's your job to solve. Okay. And when you plug these things back into here, once you find x, you would plug it back in. You would notice that these angles are completely different from these angles. So I'll just leave that up to you guys because I want you guys to do some stuff on your own. All right, let's go ahead and go to the next page. All right, now we're going to start talking about some logical stuff. Let's talk about some logic. All right, over here we have fill in the blank. Fill in the blanks that are available. I can read, I promise. Fill in the blanks with the available answer choices. Complete the postulate. All right, if two lines intersect, then exactly one line or plane contains both lines. All right, so two lines that intersect. All right, I have no idea what's going on, so I'm just going to go ahead and draw that. I have two lines, and they intersect. Perfect. I don't know how they intersect, but they do. Now, what contains both of those? Well, a line would be like my pen right here. So if I make this a little larger. All right, so does my pen contain both of those lines that I drew? No. But my plane does, which is my paper. My paper is a plane, and those two lines are on this plane. So that's the answer, plane. If 2 points lie in a plane, then the line or plane joining them also lies in that plane. I have no idea what just happened. If 2 points, okay, I have 2 points, sure, lie on the same plane. My plane is my paper. Then the blank joining them lie. Okay, so something's going to join them. All right, so how do I join these two? I just draw a line. Oh my gosh, it's a line. There you go. So there's your answer. It's a line. So notice that I just read a couple of words. I drew it. I read a couple more. Every time I read something, I immediately start drawing it because I have no idea what's going on. Little by little, it'll start making a little more sense. Okay, number 7. Okay, choose the conjecture that describes how the 8th term in the sequence is this. Okay, so okay, I have no idea what's going on. I'm just going to fake it. How do I get from, so I'm looking for the 8th term. So this is term 1, term 2, term 3, 4, 5, 6, 7. I'm trying to get to the 8th term. Now, how do I get from 3 to 20? Okay, I add 17. Okay, does that pattern keep up? If I keep doing that same pattern, will I get to the next numbers? Let's see. So I'm starting at 3. If I add 17, I get 20. That's perfect. If I add 17 again, I get 37. Again, I get 54. If I add 17 again, I would get 71. And then I get 88. And then I get 105. And then I get 122. All right, so the 8th term is supposed to be 1, 2, 2. I have no idea what these things are. So let's just figure out what they are. Add 68 to 54. I don't know what that is. Okay, so let's just do it. 68 plus 54, that equals 122. Hey, that works. That's what we're supposed to get, right? So that looks legit. But always double check the other ones. There might be a better answer. All right, add 17 and 71. I get 88. Nope, that's definitely not it because I was supposed to get 122. All right, multiply 54 times 4. That is 216. Nope. And add 34 and 54, and we get 88. Nope. So I know for a fact that my answer is A. I don't know why, but it is. Now let's see if we can actually figure this out. Okay, 68, I don't know where that came from, but 54, that's this. Now, what did we do to 54? We kept adding 17, right? I added 17 once, twice, 3 times, 4 times. So 17, 17, 17, 17. Okay, so I did it 4 times. So 17, 4 times, that's where so you added 68. That's where that 68 came from. We added 68, which is really those 17s, to that 54. That's where it came from, if you were curious. But really what we did was we just faked it until we got the right answer. All right, let's keep going. Number 8. All right, so for number 8, they said fill in the blanks using the available choices, which are down here. The choices are contrapositive, inverse, converse. Now, what does that mean? If I look at my hot topics for Unit 3, converse is you switch them, so you just switch. Inverse, you put in the words not. So it's if not A, then not B. And contrapositive, you switch and you put in the words not. So you need to remember that. All right, so here we go. Okay, we have, and I'm gonna, maybe I want to use colors. Okay, we have, okay, 2 planes intersect, and we have intersection defines lines. All right, so here we go. On the first one, we have if 2 planes define a line, which we said was going to be green, then they intersect. So what happened from here to here? All they did was switch. And what is it called to switch? That is converse. All right, over here. So we have the word not here and here. Define a line. A line is supposed to be green, and intersect is supposed to be orange. All right, so what happened from the original to here? Well, we definitely put in the words not, and we also switched. So putting in the word not and switching, that is contrapositive. Okay, and right here, we have 2 planes that do not, so we have not in these 2 spaces, do not intersect. That's supposed to be orange. And they do not, then the planes do not define a line, which we said was going to be green. All right, so how do we get from the original to here? All that happened was you put in the words not, and that is called inverse. Excelente. All right, keep it going. Number 9. All right, so number 9, we have these 2 statements. So if it is a rectangle, then it's a parallelogram. If the figure is parallelogram, then its opposite sides are parallel. So there's some overlap. The overlap is right here in the middle, right here and here. So this is called syllogism. So it's deductive reasoning, and syllogism is that you're cutting out the middleman. So we have here and here is the, so if P, then R. So basically we get if P, then R. So we just cut out the middleman. If you're given P, then you get R. So that would be your conclusion. So I wrote it, this is a better way to write that. So you're just cutting out, so if P, then Q, and if Q, then R, cut out the middleman. If P, then R. And that is syllogism. So that's if you're basically doing a transitive property kind of thing. of cutting out the middleman in words. So which one does that say that? So if a rectangle, then parallel. So opposite sides are parallel, so no. If not a rectangle, no. If a rectangle, okay, so it's C. The answer was C. If opposite side, no. Okay, sweet. And that's the best answer, C. Next one. Ooh, proofs. I love proofs. Once you know how to do it, they're not that hard. Okay, so for proofs, the first thing you always want to do are your givens. So track down all your givens in here and make sure they're written down. So what line do you see 1 is equal to 4? Nowhere, so that would have to, and here's a given though, so that'll be line 1. So angle 1 is congruent to angle 4. So we took care of that one, and we made sure it says the word given. Where does it say angle 4? Man, I'm having trouble circling that. Angle 4 and 5 form a linear pair. Well, that's line 2. And the reason is given. So let's go ahead and write down that word. So we took care of both givens and we took care of the word or words given. Now prove. You always cross out the word prove. The word prove will never be a reason. You're not allowed to use the word prove. And tricky little buggers will definitely always be an option, but it will never be an answer. So if you choose the word prove, you're just being silly. So the word prove is never allowed. And then this part right here will always be your last statement, which is right here. So it's already there. Perfect. So that is your last statement. Took care of that. Okay, now let's actually read through this and see what we can do. All right, so you said 1 and 4 are congruent. So 1 is congruent to 4. And then they said 4 and 5 are linear pair. Okay, so those were givens. We didn't jump from here to here at all. Now, how did I get from here to here? Well, 4 and 5 are a linear pair, and then right after that is saying that something is supplementary. Well, we were just talking about 4 and 5, so we're still talking about 4 and 5. So 4 and 5 are supplementary. Now, how do we get from the word linear pair to supplementary? So the word linear pair to supplementary. Well, if you look at your reasons here, linear pair to supplementary, that is if two angles form a linear pair, then they're supplementary. That is the supplement theorem. So you need to know the difference between all these. So that's a supplement theorem. They said it's a definition of linear pair. So technically that's still correct, but the better way we could have said that was supplement theorem. The supplement theorem. Okay, now how do we get from this line to this line? See how they were talking about 4 and 5, and now they're saying 4 and 5 add up to 180? Well, let's look at our definitions again. Look at our vocabulary words. So that would be, so supplementary to the word, so the word supplementary to 180 or 180 is supplementary. That's the definition of supplementary. So that is definition of supplementary. Okay, then from here, we're supposed to go to something by substituting. I don't know what I'm substituting yet, but whatever I substitute, it's going to help me get to this part. So look at line 4, look at line 6. We are, both of them still have the number 5. So what do you think you're going to replace? You're going to replace 4 with the number 1. And we're only substituting, so everything's going to stay the same, but we're going to replace one thing. So we're going to replace that 4 with a 1. So angle 1 and everything else stays the same. Angle plus angle 5 equals 180. And that's what you did. You just substituted the number 1 for number 4. And then how did we jump from the add up to 180 to being the word supplementary? So adding up to 180 to the word supplementary, sorry, there you go. So that would be right here. That's still the definition of supplementary. So definition of supplementary. Excellent. All right, and that's the answer for 10. Just faking it till you make it. All right, let's go to number 12. All right, I know we were supposed to do number 11, but we're just going to skip that for right now. All right, so let's go to number 12. Number 12. Now we have a lot of stuff going on here. But look, they only want this next line. So we actually don't care about any of this. We can just figure out what the next line is. The question is, how do we get from here to here? So what changed? I'm going to zoom in here. What changed from here to here? Well, if I focus on this, they both have 180. They both have this equal sign. And they both have STW here and here. So what happens? Well, RTS was replaced with TWV. And when you're replacing something, what is it called? That is called substitution, when you're just replacing something. So that is substitution. And that was letter F. All right, let's go to 13. This one we're going to have to read a little more because there's a lot more stuff going on. So let's see. I'm going to use colors to help me figure this out. All right, we know that these two lines are parallel, right? They said XWY. So XWY, so that's this angle right here, is equal to UTW. So here's U, here's T, here's W, and that corner is right there. So these two angles are equal to each other. What kind of relationship do those have? Well, that is, if we look at the positions of those, that's in the top left, that's in the top left, and that's called corresponding. So corresponding angles, and that was B. So corresponding, and that was B. Right here. Took care of that. Excellent. And then the next one, I'll change colors so I can help you follow me. Okay, UTW. So here's U, here's T, here's W, and I'll make this blue this time. Is equal to congruent to RTS. So here's R, here's T, here's S. So this is right here. So those two angles are equal. What kind of angles are those two? Well, you're at the same station. So what two, those right there, those are vertical to each other. So those are vertical angles. And that right there is letter J. And last one. So we got to here. They said that this angle is equal to this angle. Okay, how? How in the world did that happen? Well, if I look at my colors again, we know that this is yellow and this right here was green as before. Okay, and what happened in these two lines up here to get to here? Well, these crossed out, basically. You cut out the middle man. And so that is actually called the transitive property, where if you had A equals B and B equals C, cut out the middle man, and that's A equals C. So in math, it's called the transitive property, but with words in logic, that would be called syllogism. So that kind of sounds familiar from earlier, but with math, when you're actually solving stuff, it's called the transitive property. So this is transitive. So transitive. But these tricky buggers, there are two transitives on here. That is G and H. One of them says of congruence and the other one says of equality. Which one do you think it is? Well, this symbol says congruent. If it said equal, we would do equality. Because it says congruent, we're going to do congruence. So of congruence, and that is letter G. And that was number 13. And now, number 11. Let's do number 11. Okay, so for number 11, for these lines to be parallel, the relationship and the equation have to be the same. So the equation for that relationship has to be happy, has to be satisfied. So we talked about this earlier. So corresponding angles, now you see if these lines were parallel, corresponding angles, they should be equal to each other. Alternate interior, see how these look the same? They're both acute in this particular case. That would be equal. Alternate exterior would have to be equal, and finally, same side interior would have to add up to equal 180. Because that's acute, that is obtuse. So, right there, corresponding is equal, alternate interior is equal, alternate exterior is equal, and same side interior or consecutive interior, same thing, they add up to 180. So with those rules, you should be able to do this. All right, so for number 1, now I don't have a lot of space, so I'm going to put this way over here. All right, so for number 1, so this is question 11, and I'll zoom in here. So for number 1, they're saying that they are alternate exterior And alternate exterior is supposed to be equal to each other, right? So that would be angle 2 is equal to angle 5. Because that's what they said right there, right? And so all we have to do is replace it with the x's. So we have 6x minus 8 is equal to 4x plus 16. And now it is your job to solve. Okay, go to the next one. Number 2. Number 2 said that they are corresponding angles. Corresponding angles that would they would be equal to each other. So angle 3 would be equal to angle 6. And all you have to do is plug in the x's. So they said 5x plus 23 and 8x minus 1. You just have to plug it into here, and you'll be able to solve that. And number 3, 4 and 8 are alternate interior, so alternate interior, which also just happens to be equal to each other. So we know that angle 4 is equal to angle 8. And it's your job to solve. And finally, question number 4. It says, how can you tell whether these two lines are parallel? All right, that is that the equation of the relationship is satisfied. So the equation of the relationship is satisfied. So for corresponding angles, they need to be equal. For alternate interior, they have to be equal. For alternate exterior, they have to be equal. And for consecutive interior, they have to add up to 180. That's what needs to happen. Okay, so that's the entire study guide. You guys just need to make sure that you finish any problems that we haven't done, which is basically number 4, number 5, and all the questions for number 11. So that is the study guide. I hope that helped you out, and have a great and wonderful day.